Today we're going to be factoring with a equal to 1. When we factor with a equal to 1, remember that typically our quadratics are going to be in the form ax squared plus bx plus c. So when a is 1, that means that we just have x squared plus bx plus c, which makes this kind of like an easy factoring problem, because it's always going to factor into this form if it can factor. Your x will always be the first two numbers in each parenthesis. And then your second number is what you have to figure out. You're always thinking of numbers that multiply to c, meaning your constant term, and add to b, meaning the number in front of the x. And there's a lot of different ways and methods you can do this. So let's look at an example. How about x squared plus 3x plus 2? So first, you know you're trying to break this down into double parentheses. And since your first term is x squared, it's x times x. Now look at your last number, your c. You want to list all the numbers that would multiply to c. In this case, the only numbers that multiply to 2 are 2 and 1. So you actually only have one option here, which makes it kind of simple. 2 is going to go in one position, and 1 is going to go in the other. Now, I always call this the rainbow check. So you're multiplying your inner terms to make sure they add up to 3x. So this is 2 times x, which is 2x, and 1 times x, which is 1x. So if you look, 2x and 1x add up to give you 3x. And since 3x is positive, you have pluses. So your answer is x plus 2 times x plus 1. Let's look at one that's slightly more complicated. How about x squared plus 7x plus 10? So again, you're trying to go for double parentheses. That is your goal. When you have your first number being x squared, the first position in each parentheses is going to be x, because x times x is x squared. So now you're looking to your last number. List your numbers that multiply to 10. So you have 1 times 10 or 2 times 5. Now you're looking for the combination that when you add them up, you get 7. So in this case, 1 times 10 and 2 times 5. 2 times 5 is the only one that works, because 2 plus 5 is 7. Now you can do a check. 2 times x is 2x. 5 times x is 5x. So you have 2x times 5x, which adds up to be 7x. And since 7 is positive, both of these are going to be positive. So your answer is x plus 2 times x plus 5. Let's do another example. How about x squared minus 9x plus 20? Again, since the leading term is 1, it's going to be x and x. So now you look at your last number. Think of all the numbers that multiply to 20. And this might jump out at you right away. But if it doesn't, this is when I just make a list. So I'm looking for a way to get 9. Keeping in mind that this 20 is positive, so both of my numbers are going to have the same operation. 1 and 20 make 21, 2 and 10 make 12, and 4 and 5 make 9. So this is the option I want to go with, 4 and 5. Now, do your rainbow check. This is 4x, and this is 5x. Now you're looking for 4x and 5x to give you negative 9x. Right now they're positive, which means that you have to think a little bit. You have negative 4 and negative 5. That gives you a negative 9 when you add them up. So both of these numbers need to be a negative. So your answer, x minus 4 times x minus 5. Let's tackle a couple where you're going to have opposite signs. How about x squared plus 7x minus 30? Again, since our leading coefficient is 1, we know that our first numbers are going to be x and x. Now look to the 30. Your numbers that multiply to 30 are 1 and 30, 2 and 15, or 3 and 10. Now notice this is a negative 30, which means when I multiply to get a negative 30, one number has to be positive and one has to be negative. I just have to assign them appropriately. So looking here, I'm looking for numbers that are basically going to subtract to 7 this time, because that's a negative. So instead of numbers that multiply to 30 and add up to 7, I want numbers that multiply to 30 and subtract to 7. So if you just do a bit of subtraction, we'll worry about positives and negatives later. But 30 minus 1 is 29, 15 minus 1 is 13, and 10 minus 3 is 7. So this is the pair that we want, 3 and 7. Oh, 3 and 10. So again, we are looking to figure out which one needs to be positive and which one needs to be negative at this point. I have a positive 7. So it's either 10 minus 3 or 3 minus 10. So 10 minus 3 is 7, but 3 minus 10 is negative 7. So since I want a positive 7, I'm going to do positive 10 and negative 3. So the negative 3 comes from the inners, so this is your negative term, and that is your positive. So x minus 3 and x plus 10. Let's do one more. How about x squared minus 6x minus 40? And again, as you do these, you're going to get pretty fast at them, especially when the leading term is 1, because this is x squared, so x times x is x squared. Now numbers that multiply to 40. 1 and 40, 2 and 20, 3 doesn't divide, 4 and 10, or 5 and 8. Again, this is a negative 40. So you're thinking of numbers that are going to multiply to negative 40, which again means one number is positive and one number is negative. Which basically implies that we are going to be subtracting these numbers. So let's just do a little bit of subtraction. 39, 20 minus 2 is 28. How about 18? Ten minus 4 is 6, and 8 minus 5 is 3. So we're going for 6, numbers that multiply to 40, but give us 6. So this is the pair that's going to give us 6, the 4 and the 10. So we're going to do our rainbow to figure out which number really needs to be positive and which number needs to be negative. So to get negative 6, I either need to do 10 minus 4 or 4 minus 10. 10 minus 4 is positive 6. 4 minus 10 is negative 6. Since I'm going for negative 6, I want to have a positive 4 and a negative 10. So positive 4 and negative 10. The positive came from the inside. The negative came from the outside. So my answer is x plus 4 times x minus 10. Good luck.